Hello and good morning. In this video I am going to estimate and interpret uh, Tobit regression model, and I am using Status software. The Tobit model is also known as a censored regression model. It estimates linear relationships between variables when there is either left censoring or right censoring in the dependent variable. Left censoring is also known as censoring from below, and right censoring is also known as censoring from above. Censoring from above takes place when cases with a value at or above some threshold all take on the value of that threshold, so that the true value might be equal to the threshold, but it might also be higher. In the case of censoring from below, values those that fall at or below some threshold are censored. Let me take a hypothetical example. Let us suppose we have a situation in which we have a measure of academic aptitude, say for example a GRE score, which is scaled on 200 through 800. The minimum score could be 200 and the maximum score could be 800, and which we want to model using reading and math test scores, as well as the type of program the student is enrolled in, and that could be academic, general and vocational. So it means here our dependent variable is aptitude, which is denoted by apt. Our two continuous or scale variable independent variables are reading and math, and we have one categorical independent variable. It has three categories: academic, general and vocational. The program here is that students who answer all questions on the academic aptitude test correctly receive a score of 800, even though it is likely that these students are not truly equal in aptitude. Similarly, students who answer all of the questions incorrectly, all such students would have a score of 200, although they may not all be of equal aptitude. Let me describe the data. So we have a hypothetical data with 200 observations. The academic aptitude, that is the GRE score, is a variable which is denoted by APT. The reading and math test score are read and math respectively. The variable prog is the type of program the student is in. It is categorical or nominal variable that takes on three values. One stands for academic, two represents general, and three represents vocational education. Here is the descriptive statistics of the three variables that we are using. Apt, read and math. These are the three scale variables. We have their total number of observations, their mean values, their standard deviations, their minimum and maximum. We may note that the lowest score for the aptitude or the apt is 352. No students received a score of 200, the lowest possible score, which means that even though censoring from below was possible, it doesn't occur in the data set because the minimum score is above the lower threshold. In order to run and estimate and interpret the results, I will open the data file. Here is my data file, and this data file is known as Tobit data. Since I am using three variables, three continuous variable and one categorical independent variable, so I will first give summary statistics of aptitude, read, math and prog. So again, these three, the first three, that is apt, read, math, these are quantitative variables, so we have their means, standard deviation, minimum and maximum. The last variable prog, that is a categorical independent variable. It has three values. So let me tabulate so that I know the frequency of these variables. So this is one stands for academics, and total number of students in this program are 45. In general 105 students, in vocational there are 50 students, and the total number of students is 200. After this, let me check the histogram of my dependent variable. So my dependent variable is aptitude, so let me this, and after this I will also check this, because I also need normal density plot, so I will check this box. After this I will so here is my histogram of the aptitude, that is my dependent variable, and this is the normal plot fitted to this data. Now we can note that there are a large number of cases between the score of 750 and 800, but the normal plot would expect otherwise. So there is a censoring from above in this histogram. After this, I'll correlate reading, math score, and aptitude. So I'll go to this, and after this I'll go to correlation. So aptitude, reading, and math, and here is the correlation matrix. Now the correlation between aptitude and reading score is 64, and the correlation between aptitude and math score is 0.733, and the correlation between reading and math is 0.6623. Now let me see the graph matrix of these variables. Now this shows this is the scatter plot of reading and aptitude, and this is the scatter plot of math and aptitude, and you see there are a huge collection of points at the top of this scatter plot, and similarly there is a huge collection of points or scatters above this. So this is because of censoring from above. After this I'll go to estimate my model, and that is Tobit. I'll click on this, and after this let me first remove all this, because I had done this once before, and similarly this one. So my dependent variable is aptitude, and order to one of my independent variable is reading score, which is continuous. I will check this box, and I will add to the variable list, and then I will add another variable, that is math. This is also continuous. So, and finally I have one categorical variable. Since this is categorical, I will uncheck this and I will add it here. So here is a, and since there is a censoring from above and the maximum score could be 800, so I'll write 800, and after this I'll submit. At here is my estimation of the model. So the command is me_tobit. Apt is my dependent variable, read and math are my continuous independent variable, iprog is my categorical independent variable, that is nominal, and UL means upper limit, and this is censoring from above. So this is the iteration history. Here are some model level of statistics, number of observations, and there are 183 uncensored, and this is left censoring, and 17 observations are censored from above. This is the Wald chi-square, this is the p-value of Wald square, and this is the likelihood. This is the main effect of reading, and this is the main effect of math, and these are the main effects of program. Now what does this mean? The coefficient of reading means that since the sign is positive, so it means a 1 unit increase in reading score leads to 2.7 unit increase in the aptitude score. Similarly, a 1 unit increase in math score leads to almost 6 unit increase in aptitude test. And here is the program. These are the two dummies. Academic program has been taken as a base category. 2 represents general education and 3 represents vocational education. Now this is minus 12.71, so it means that the aptitude score of those students who are in general program have 12.7 point less score in the aptitude as compared to the score of students in the academic program. Similarly, students in the vocational program have 46.14 point less score than those students who are in the academic program, and these are their standard errors. These are the z values, and these are the z statistics. These are their confidence interval, and this is the variance of the residual. So after this, let me test some assumption. Sorry, this should be test PROG. IPROG. Now I'm going to test a null hypothesis that the coefficient for program 2 and program 3 are equal to 0 jointly. But this p-value of chi-square with 2 degrees of freedom is less than 0.05. So we can safely reject this null hypothesis, and our conclusion is that the coefficients of these two programs, that is the general program and the vocational program, are not jointly equal to 0. This because this coefficient is highly significant, this one is not significant. We can also test an alternative hypothesis test. 2 prog is equal 3 prog. So here I am testing that the coefficient of program 2 is equal to the coefficient of program 3. So this is my null hypothesis, or the difference between program 2 coefficient and program 3 coefficient is equal to 0. But the chi-square value is 6.66 and its p-value is less than 0.05. So we reject this null hypothesis that the two coefficients are equal. They are not equal. After this, I can estimate the residual. I have already done this before. Let me try if I can drop the selected variable. Yes, and let me also drop this variable, which is now I can predict y, or ei, predict ei resid. So by giving this command, I predicted or created this variable which is equal to the y hat, that is the estimated value of y hat, and that is equal to the residual, that is the difference between the observed y and the estimated y, or the predicted y. After this, I can show through a plot of the residual and the observed value and fitting the plot. So let me do that in a different way. So let me go to static graphs and scatter. Here I will create, and that is scatter. This should be this residual value, and here I will write my dependent variable, and I'll start this on X. I'll accept. So this is my scatter plot. Now I want to fit plot to this. So after this, I'll click on this, plot, and again erase it, and apt, and now if I submit, this is my plot fitted for this data. After that, I would like to make prediction for this data, and I can do that by clicking on post estimation, and after that I'll click this and I will launch, and let me delete all this and delete all this. I'll do this here, and my covariate is math, say for example, and this is 40 with interval of 10 to 80. Let me see what does it do. So these are my marginal expected values of the aptitude score. So let me explain this for you. The command is margins program at the score of maths starting from 40 through 80 with the interval of 10 marks. Total number of observation 200, and this 8 means someone who has got 40 marks in math, 2 means someone with 50 marks in math, and so on. Finally 5 stands for someone who has got 80 marks in math. Now this coefficient or this margin means that someone who got 40 marks in mathematics and he is in academic program, that the marginal expected score in the aptitude score is 587. Similarly, someone with score 40 and in general program, he or she has the expected marginal predicted score of aptitude 574, and for someone in the vocational the expected score is 540. If I scroll down here, it means someone who has got 80 marks in math and he is in the academic program, then the marginal expected score in the aptitude test is almost 824. And for someone who scored 80 marks in maths and he is in general program, his or her marginal predicted score in the aptitude test is 811, and for someone in the vocational the marginal predicted score in the aptitude score is 777. And we can also make a profile plot of this graph. So sorry, let me go to the correct place, and let me do this and launch. I'll do this at math, and here I will mention program. So now you will see this is the graph, the predictive margins of the program. So let me also do one thing more, legend, and I want to have these legends in one line, so it should be one row. Yes, accept, and if I submit, now these legends are in one line. So this blue line shows those who are in academic program, this maroon line shows those students who are in general program, and this green line shows those who are in vocational program. So the marginal predicted score of those who are in the academic program are higher at all marks in maths, followed by those who are in the general education program, and finally we have the vocational program, in which the marginal expected scores on aptitude test for various students who have got either marks 40, 50, 60, 70 or 80 or lower than the respective scores for those who are in the general education program or in the academic program. So this is how we estimate, interpret Tobit regression model, its marginal expected values, and its profile plot. If you have any question, you may ask me a question in the comments below, and I'll try my level best to come up with the possible answer. I thank you very much for watching this video. Kindly do share this model or this video with your students, with your colleagues in various WhatsApp groups, so that it could reach to maximum possible number of people. Thank you. See you again.